What causes intermodulation distortion in analog amplifiers? Imagine you're trying to listen to your favorite song, but suddenly you hear strange, unwanted sounds that weren't part of the original music. These are often caused by something called intermodulation distortion in analog amplifiers. It might sound complicated, but it all comes down to how the amplifier handles multiple signals at once. When two or more signals enter an amplifier, if the device isn't perfectly linear, it can mix these signals together. This mixing creates new signals at frequencies that weren't there before, called intermodulation products. These new signals can interfere with the original ones, making the sound or data less clear. In an ideal amplifier, the output would be a perfect, scaled-up version of the input signal, with no extra sounds or frequencies added. But real amplifiers are made with active devices like transistors or tubes, which don't behave perfectly. These devices have nonlinear characteristics, meaning their output doesn't increase proportionally with the input. When signals are strong or multiple signals are present, these nonlinearities become more noticeable. They cause the output to include not just the amplified input signals, but also new signals formed by the mixing of the original ones. For example, if two signals at frequencies of 50,000 Hz and 50,500 Hz are fed into the amplifier, the nonlinearities can produce signals at frequencies like 100,500 Hz or 50,500 Hz minus 50,000 Hz, which is 500 Hz. These new frequencies are called intermodulation products. They often fall within the range of the original signals, making them hard to filter out. This can cause audio distortion or interference in radio signals, which is why minimizing this distortion is so important in amplifier design. The mathematical way to understand this involves modeling the amplifier's behavior as a polynomial. The output is expressed as a sum of terms involving powers of the input signal. The first term is linear, giving the desired amplification. But higher-order terms, like the second or third powers of the input, create these unwanted mixing products. Third-order nonlinearities are especially problematic because they generate intermodulation signals close to the original frequencies, making them difficult to filter out. Designers try to reduce intermodulation distortion by choosing better components, using linearization techniques, and adding feedback circuits. Feedback helps control the nonlinearities, but it can't completely eliminate them. Certain types of transistors or amplifier configurations are more prone to producing intermodulation distortion, especially at high signal levels or in the presence of strong interference signals like power line noise. In audio and radio systems, intermodulation distortion can seriously degrade signal quality. It causes unwanted tones that interfere with the original sound or data, making the output less clear. That's why engineers pay close attention to the nonlinear behavior of their amplifiers and use various methods to keep this distortion as low as possible. Understanding what causes intermodulation distortion helps in designing better, cleaner amplifiers that faithfully reproduce signals without adding unwanted noise or interference.